for Tech Talk with Unconventional Solutions. We are going to talk about the overview of NSF ANSI CAN 600, which is the new NSF regulation that has come down for potable water applications. Oh, come on. There we go. So we'll talk an overview a little bit about the new CAN 600 regulations and summarize the pass and fail criteria, because that's really what it's all about. What does this mean to everybody in coatings moving forward, applicators, manufacturers, and/or end users? If we have time, we'll talk a little bit about our solutions from Seal for Life, which are LifeLast, which is our 100 solids NSF approved DuraShield, and go through a couple case histories quickly for you as well. So does this new regulation, the NSF ANSI CAN 600, actually replace the old CAN 60 and CAN 61? Short answer is no. This is a companion standard to the flagship, which of the North American standards of NSF ANSI CAN 60 and 61. So all three of these kind of go together. So until 2018, the content comprising Standard 600 was always located in Annexes A, C, and D in CAN 60 and 61. Annex A in both standard contain the toxicological risk assessment. So in other words, what's in the product? Is it going to harm people under testing if it's been put into a potable water application? On the other hand, Annex C from CAN 60 and Annex D contained, from CAN 61, contained the pass-fail criteria. So what does that mean? It means that the joint committee that oversees CAN 60 and 61 decided to separate these sections into their own standard, so it would serve as a reference standard for all drinking water. This consolidation was intended to make the toxicology data more accessible, as well as make it easier to update and navigate the pass-fail criteria. Thus, the new reference standard was then designated CAN 600. So in August 2014, Health Canada published new MAC values, which is maximum allowable concentration, for three solvents: toluene, ethylbenzene, and xylene. CAN 600, formerly Annex A of CAN 61, requires that a substance regulated by the US EPA or Health Canada be evaluated according to those assessments without additional toxicological evaluation. Consequently, the new maximum allowable concentration values for these three solvents were published as updated criteria under CAN 600. Corresponding single product allowable concentration values for each compound were set at levels 10-fold lower than the maximum allowable concentrations that were previously in CAN 60 and CAN 61. So NSF set a 5-year implementation period for products to comply with the updated criteria for these solvents, with a compliance deadline of January 1st, 2023. It's important to note that this compliance deadline applies only to the three solvents with reduced pass-fail criteria, which is toluene, ethylbenzene, and xylene. So the reduction in pass-fail criteria for these three solvents constituted a substantial change from the previous criteria. These solvents are widely used in coating formulations, sometimes at quite high levels. So the dramatic change in the allowable leaching levels for these solvents has meant that manufacturers have had to consider reformulation or replacement of some solvent-based coating products that are currently certified under CAN 61. So after the January 1st, 2023 implementation deadline, all products certified to CAN 61 will be required to meet the new criteria in CAN 600, including the most current health effects for xylene, toluene, and ethylbenzene. So basically, what has happened is those three solvents that are generally used in, we all know, epoxies, usually use toluene, ethylbenzene, xylene, other formulations use them. There's, mixes. But the previous limit, if you can see, was 1,000 grams per liter. Then you got to 100. The updated SPAC and the updated TAC, which is total of allowable concentration, used to be 60. Now it's 6. So as you can see, those maximum values have reduced tenfold, which now means that most of those products that contain toluene, ethylbenzene, and xylene would not pass the updated ANSI CAN 600 solvent criteria. So what does that do for the industry? What does that mean for everybody? Well, most coatings right now will now be 100 solids formulations to meet the new testing criteria. New application techniques and products will need to be considered as well. Solvent-based products with xylene, ethylbenzene, and toluene will become obsolete for potable water. So any of those old products that might have been 70% solids, 80% solids that were easy to use, multiple passes, you might do in 2, 3 coats and could do small diameter pipe, is now going to be very much harder to do with 100 solids products, such as epoxies and urethanes. How do you coat those small 2, 3 inch diameter pipe? It can be done, but you don't have the availability now of having those thin film coatings where you could put 4 or 5 mils down in a strip, another 5 mils, another 4 or 5 mils to meet your spec. This is what is changing the industry that's out there. A lot of people don't know that right now. There's still people out there using some of the old NSF CAN 61 products. So once again, it's eliminating those 3 solvents, or basically putting the allowable concentration so low that any percentages of these into your coating system in manufacturing is not going to pass the CAN 600 regulations. So we're going to talk a little bit about products that you guys have at your unconventional solutions that are available to you and your customers. Benefits 100 solids polyurethanes. These are products that now meet the CAN 600 NSF regulation. They have better flexibility, impact, and abrasion resistant than most epoxies. And I say most epoxies because there's always new formulations coming out, flexible epoxies available. They're highly chemical resistant, excellent water vapor, permeability, and absorption. So that means that water vapor penetration is what you don't want into a coating. The lower that number is, the less likely it is going to allow water to pass through the coating to the substrate, which is now going to start a corrosion cell. These can be used on just about any substrate. We use them water, wastewater, non-ferrous steel, wood, concrete, and other substrates. We do PVC as well. Fast cure times, we can get that to cure in seconds, or we can have a cure in 3-4 hours, just depending on what the need is and for the applicator. Of course, they meet AWWA C222 and the new ANSI 600 for potable water. They're also FDA approved for dry food storage. So think if you any type of dry food powder, grains, hauling grains, these can be used as well. Excellent application characteristics. They're high build with NSF certification up to 250 mils if you need. Generally speaking, we follow AWWA C222, which is 25 mils or more is what's required for our LifeLast product. But once again, they can build it up to 250 mils thick for different applications. Disadvantage, it's not UV stable. So it's an aromatic polyurethane. Does not chalk, but darkens over time if exposed to sunlight. So unlike, fusion bond epoxy that they use on pipe for potable water, we've had our products sit in the field in Texas for 8 years and had them tested. They don't lose DFT from chalking, might lose 1 to 2 mils over that time. The biggest thing is they keep their flexibility, which is what happens to fusion bond epoxy. It becomes more rigid if it's exposed. The other drawback is 60 C, 140 Fahrenheit in immersion. That's the top end, and not good for hydrocarbons. So it doesn't like oil. So you wouldn't use that for oil and gas primary storage at all. They come in 3 versions, 110, 210, 310, as simple as 110's a 1-to-1, 210's a 2-to-1, 310's a 3-to-1 ratio, all once again set up for 110. We can have a cure in seconds for manufacturers, 310, which cures for immersion in about 15 hours. So here's just some pictures of DuraShield 110, 210. It's extremely fast cure speeds. We can adjust the cure speeds on all of these products and tailor them for the application, whether it's OEM or for an applicator out in the field. Excellent impact, abrasion resistance, and flexibility. Of course, they're all CAN 600 certified. That's the 110, 210 products. Typical industrial applications, of course, steel water pipe, inside, outside, wastewater pipe, potable water, hydroelectric penstocks, reuse lines, irrigation lines. We can do horizontal directional drilling with this product by itself, where our sister companies, Ganusa on the Seal for Life field joint side, they sell a product called Powercrete, which is a sacrificial epoxy that goes over fusion bond epoxy to save it from being delaminated when it's pulled through horizontal directional drilling boreholes. So that would be something where they've drilled a borehole straight through the earth somewheres, and they drag that pipe right through from one end to the other. DuraShield 310, this is our most tenured 100 solids polyurethane. Aggressive wastewater case histories. We use this one mostly on steel pipe and for concrete because it has the best flexibility. It has about 40% flexibility, so it'll move with the concrete substrate when the concrete expands and contracts. It's slower curing, more of a field application product, 72-hour recoat window, primarily used as a hand spray and field joint coating and lining. For use on concrete and steel, that's a fish ladder that's up at the top there, hatchery. It's painted in different colors just to make it look like the fish's natural environment. What it does is it's also smoothens the concrete surface, so when the fry run up and down against the concrete, it's nice and smooth, so it doesn't damage the fish as well. Bottom is just your standard bioreactors in a wastewater facility. So these products are also highly chemical resistant. And most things you're going to find in a water treatment plant or wastewater plant for chemicals for primary containment, these products can be used as well. Similar applications, we do manholes with these as well. So we'll do a complete manhole relining. The one on the bottom is just an interesting one. It's a customer that we have that takes sea containers and makes pools out of them. So they're just using the non-NSF version here in light blue to make a pool, backyard pools that will be buried in the ground. So won't spend too long on this. I think we're getting close to time. I don't know if you guys got to run right now, but or want me just to continue. I can keep going because there's some case histories coming up, but application, plural component pump, cartridges, and hand application. These are videos in here, but I won't play the videos for due a time. But the spray application is basically a pneumatic caulking gun. This here at the end is a static mixer, and this is an atomization tube, so you actually get a spray pattern coming out the end of this Sulzer gun. Just one way for smaller areas that you can be able to apply the product without plural component equipment. Oh, yeah, now it goes. Well, we'll continue on because it's a 5-minute video. This is a plural pump. Now, this one's kind of neat. I'll show you this one quick. This is a spinner head inside a 3-foot diameter pipe. He's dialed this in to have a winch pull this back at a certain speed, and the RPM of the spinner head, they've got exactly 30 mils everywhere on the inside of this pipe when he completes this. Well, that's a standard application of what they'll do with plural application inside the pipe without a man inside spraying. This is a JARS kit, joint and repair kit. So once again, it's a hand applied kit, mix A and B together, use a brush, and you apply that to your girth welds, joints, holidays, repairs, anything you need to do. So it's once again user-friendly with 3 different ways for application. Now we'll just get into some case histories quickly for you guys, just to give you an idea of where it's used. There's a pipeline in Texas, 5.5 miles of 78-inch welded steel pipe. You can see they're not concerned. They basically wrap the pipe in a chain and use a backhoe to move these things into place. That's how highly abrasion resistant these products are. We show some with a 4-inch dent in the side of a pipe that was still holiday free. Of course, they couldn't use it because of the dent, but that just shows the flexibility of the product. Here's a clarifier tank for you, blue heron paper mill. So once again, use the 310. This is 10,000 square feet of DuraShield applied at 125 mils on concrete in under 72 hours. These products, the 210, 310 cure for immersion, 310 in about 15 hours, 210 in about 6 hours. So they can be put right back into immersion in non-NSF applications. For NSF applications, NSF requires 72 hours cure time before it can be put into immersion. Here's just another one, the Central Oregon Irrigation District, 108-inch diameter pipe installed for 13,000 feet, lined at 40 mils on the inside, simply because you've got, this is where it's transporting water, it's like a mini penstock, rock, silt, debris coming down the inside, so you want to make it a little bit thicker than the standard 25 mils that we have on the outside, which meets the AWWA C222. This is an interesting one. This is an HDD application. As you can see in the 2-side pictures, they drilled borehole is going through the ocean in to the inland. So they're going through 2 sides to support bringing potable water into a community. What they're doing is doing the girth welds on the barge out there in the top picture. So as they pull that thing through, they're coating the girth weld. It's curing in 1 to 2 minutes, and they keep pulling that, and they will sling that pipe and pull it right through that borehole to the other side. So 25 mils on the internal. Of course, you see we go a little bit thicker on the outside at 70 mils, simply because you have that abrasion. We will lose a few mils, but not enough, and not to create holidays in the coating or damage to the coating that you need to repair. And that's it for the presentation. Was there any questions from anybody? Nothing? Quiet crowd.
Yeah.
But
now, with that board, would they have to do an artificial coating over top of that to protect it?
Oh, that's just the standard, that one there. That's what I'm saying. We don't need sacrificial for that. We get 120 pounds direct impact with these products. 210 is actually 160 pound direct impact. So compare that to epoxies. And like I say, most epoxies, not all of them, there's some that are flexible, have a little bit better impact, but standard epoxies that you're going to use in this situation, 8, 10 pounds direct impact, if that. Their flexibilities are usually 3 to 5%, where once again, 310's 40%, 210's about 15%, and 110 being the hardest is still at about 10%. So, these are the things that they take into conjunction. Where that comes into play, if you can see the bottom picture here where they're slinging this, well, there's 70 mils on the outside, 25 mils of coating on the lining on the inside. They can sling that in a U, and the coating does not crack. It doesn't break. It doesn't fracture. So they know that they can put 70 mils on. And I've had a lot of engineers call and ask, well, what's your limit for HDD? Well, you can put it on 250 mils thick. It does not affect these products. It will take a 3/4 inch mandrel bend test and pass at 70, 80 mils. So that's just taking piece of steel, bending it around a 3/4 inch mandrel. And now you check for holidays, cracks, and anything in the coating surface, and it passes those tests at that thickness. So that's one of the bonuses for HDD. You don't need to put that second coat of something on there for sacrificial protection. Anything else?
No, you answered mine.
All right. Well, if anybody has any questions, you know how to get a hold of me. This product, like I say, you guys have on hand. Great product for potable water or for concrete restoration. We've used it on floors. These were actually designed to begin with as cast polyurethanes to replace rollers in a paper mill. So if you know those big steel rollers and they all have polyurethane on them, that's where this product originated back in the 80s. And then started going into the coating industry as well. So just a little background on it, but we do have 40 years of case histories and a ton of testing on these products as well. Sulfuric acid, 50% concentration, no problem, primary containment, H2S in wastewater. These are all areas where these products live. So hopefully we gave you some information today on NSF. Big thing about that is, remember, it's those 3 solvents is what the changes are, and what percentages are available or allowed to leach out of the coating over time, and the solvents will. So that's changed that, and like I say, most you're going to find are now 100 solids epoxies, 100 solids polyurethanes that are going to be used in the potable water market. So thank you very much, everybody. Appreciate your time.